Constellations. Here we go. So the first thing we're going to address is obviously what a constellation actually is, because it'd probably be good to know what one is since we're going to talk about it. So constellation basically is a group of stars that appears to outline the shape of something. The big thing we have to mention here is that they are in fact not real.
In fact, this is mainly why we're talking about them,
exactly.
so that you know
they're imaginary groupings, or things that we, from our perspective, have looked up and said, hey, that kind of sort of looks like a dog, so we named it that.
A random amount of stars and drew lines between them and then said, hey, that's a big bear.
Exactly.
Or a cooking pot, or an archer.
So they have mythological significance, though, because a lot of times they were tied back to, the Greek and Roman mythology. There's about 88 named constellations. I will mention, though, that even though they're not truly real, you can use them because they're in the same place at every year to kind of identify where some stuff is, or tell time a little bit, like for farmers.
And that's why farmers like to use them.
Right, and myths. There's good stories about them. Yay, Orion, the great hunter, arrow, boom, killed you, got it.
But really, before we were good at timekeeping, let's be honest, farmers did use these to figure out when it was time to plant crops and stuff.
Right.
Oh, I see that constellation. So they have had a use in the past, so we don't mean to be constellation haters. But,
they're neat. They're cool to talk about.
Right now, they're not really, used
they're
for
not
much
really
than
used
anything.
so much for navigation unless you're out lost.
Yeah.
They have better technology now to help us navigate the globe.
Yeah.
But they do still have some kind of historical significance because early people would use them for navigation, for hunting, for making settlements, and for farming and things like that. And they were good for telling stories, and that which brought people
And another
together.
interesting thing, though, is that even today, people who study space and study stars, they will reference the location of other stars based on, they'll be like, oh, it's found within the Ursa Major constellation, because it's easy for people to get, rather than say, like, it's in quadrant X5432 or whatever.
So most astronomers, if, like, for example, Venus is going to be out one night, they'll say, well, look for Orion, and then look to the left, and you'll see Venus. So astronomers still use this as a reference point. So every astronomer knows their constellations, even though they're not really useful for,
Well, I kind of feel like a jerk now for saying they weren't real. But.
And by the way, Ursa Major, for example, is actually a part of a constellation. So the Big Dipper is actually, the Big Dipper is part of Ursa Major.
The Big Dipper is the back of the bear, and if you look in the picture right over there's a little green pan that you can kind of see in the rough outline that they call Ursa Major, which just means big bear.
So, and here's one thing to keep in mind that we haven't been explicit about. So, let's say from Earth, these stars all look like they're relatively similar distances, when in reality, one might be 300 million miles away and one might be 5 million miles away. They look the same to where we're at, but if you were to go a totally different area of space, these constellations would look totally different. So that's why we say they're not really real. They're kind of
looking at a point right here and a point right here. They might look like they're next to each other, when in reality,
it's a frame of reference thing. Yeah.
Right.
All right, so let's move on to galaxies, though.
Which are real.
Very real. Yeah. By the way, what galaxy are we in? Do you know?
The Milky Way.
Right. So galaxies. Galaxies have a lot of stars, like billions of stars.
Yes. In a galaxy, there are
billions of stars.
Billions with a B. Now, let's keep that in mind as we work on scale in class to get an idea.
So all these are bound together by gravity. In fact, there's a giant gravity source in the middle of our galaxy. Do you guys know what it is?
Ours is a black hole.
Yeah, we have a giant black hole in the middle of our galaxy.
Not every galaxy.
That's not how it works in every galaxy. But there's like a gravity center that holds all these stars together.
Yep.
And the universe is made out of galaxies. So if you're trying to figure out where a star's location is, well, you'd go by galaxy, I suppose. But we really only know the stars in our own galaxy. Stars.
They're made up of stars and any kind of
solar
arrangement.
systems,
so
too,
we have
any
solar
planets around
systems, and they're like our solar system.
Right.
Inside the Milky Way galaxy, there's other solar systems.
Yep.
So there are billions. Astronomers think there are billions of galaxies in the universe. As we said, there's billions of stars. So I mean, that goes to show you how big space is.
Oh,
right?
it's
there's a number
comprehensively vast and neat.
And this is a real picture. We've shown you a lot of artistic pictures.
Right.
This is a real picture of galaxies as seen by Hubble telescope, our most powerful space telescope.
So what are the
It orbits outside Earth.
Are they the bright white spots on the
Yeah. I thought you were asking me to name one.
No.
I know Andromeda. That's it.
Yeah.
Yes,
So you're not actually looking at stars here. All those dots are galaxies.
Yes.
Right.
Yeah. So those are galaxies.
To make sure you get that, so from Earth, when we just look up and see the bright spots, those are stars that are in our galaxy.
If you get far enough out into space, though, you don't see stars. You see stars, but you also see galaxies.
And those bright dots on that picture right there are actually billions of stars and other celestial bodies together,
In galaxies.
closely, relatively speaking.
Right. So there's 3 types of galaxies we're going to talk about today. The first is called spiral galaxies.
That's what we
Hooray
are.
for us!
So, spiral galaxies have a nucleus, just means center of bright stars, and flattened arms that spiral, hence the name spiral galaxy, around it.
Right.
The older stars are going to be found near the nucleus. The younger stars are found on the outer edges of it. Examples would be like the Milky Way and Andromeda. And it might be kind of interesting to note that ours is our solar system, our star, which our planets go around, is found more on one of the arms on the outside.
Right, yeah, we're sort of towards
we're
the
not near
outskirts of
middle,
ours.
don't-
Now, when you look at, so in the upper left, that's a picture of the Milky Way. Now, is that really a picture of the Milky Way?
No.
Do we have any photographs of our galaxy?
No, we
We
don't.
don't, because we haven't spent spacecraft out that far.
No.
We just exited our own solar systems. We're not even close. So, really, any pictures of the Milky Way are just that. They're artists' renditions of the Milky Way. We have a good idea of what it looks like, but it's not actually a picture.
Or people use other pictures of other galaxies we've seen, and
Yeah.
they say that it's ours.
Right. Now, I'm not sure about the bottom left one. I think the one on the right, though, is also a artist rendition.
I think so.
But anyway, we do have pictures of some galaxies, real pictures and good pictures, but it's not that easy to obtain. You need to use really high-tech telescopes and
Right,
whatnot.
and you usually have to be outside of our atmosphere because the
Right,
atmosphere messes up a lot of that.
Yeah,
Right,
There's a
yeah.
lot of light.
So there's another type,
pollution in
Mr.
that.
Harkins, of galaxies. Can you?
We have elliptical galaxies, and just like their name implies, they're like an elliptical shape, so kind of like a squished down circle.
Like a football, right?
Yeah, if you take a sphere like a ball and you squish it down, it's like a football-shaped galaxy, or like your little flying saucer-looking type thing.
Or a
They're-
rugby ball.
What was that?
Or a rugby ball.
Or a rugby ball.
Australian rules football.
There you go. Any
Or
one of
Canadian rules
those.
football.
Yeah.
And you squish those things down. They don't have arms. They're a lot like ours, where they have that bright center.
Yep.
That nucleus is very bright. It's got a lot more matter there and that. It's mostly older stars than that. But instead of having those long trailing arms that kind of spiral out, stop it right before you get to the arms. It's just that core and then a little bit of fluting out to the edges. And that's it. And they don't have a whole lot of gas or dust, which is mainly what the arms are on the spiral galaxy that we see. And there are,
Right.
of course, stars and things there.
Right.
And finally, we have some irregular galaxies, and they don't
Isn't
really
that
have a
what else?
well-defined shape because they don't have a lot of mass to them.
Mm-hmm.
So they have a lot of dust and gases, but they don't really have
A lot of
gravity,
heavy gravitational
a lot of
bodies.
gravitational
Right,
field. So they're kind of irregularly shaped. Now, a little bit about our galaxy. Once again, that's not a real picture; that's an artist picture. But we are a spiral galaxy, as we've kind of referenced.
Mm-hmm.
Right.
It is 100,000 light years across.
What does that mean?
That
100
means
light year. What is
a
that?
light year is the
I don't get it.
distance that light can travel in 1 year.
Okay.
So
Is that
100,000 light years means that is the distance that it would take light to travel, or it would take 100,000 years for light
Like
to travel that distance. For
Okay.
reference, we just exited the solar system, and I remember reading that it takes 17 to 18 hours, I think, to get communication back from
Wow.
our spacecraft, which means that, and we send in the form of radio waves, which is a form of light, so that means that the edge of the solar system is about 18 light hours away.
Okay.
So our solar system is not even close to a light year across. It's like about 1.5 light days across. So
And if you think about
So,
it, I guess it makes sense
yeah.
because light travels at basically 3 times 10 to the 8th, or what is that,
30 million.
30 million
Meters per second.
meters per second,
Mm-hmm.
Yes.
which is fast, but even that is like ridiculous when you go fast.
Yeah.
Okay, cool.
So in our sun is just one of billions of stars in our galaxy.
Mm-hmm.
Okay, we kind of gone over this. And our galaxy actually orbits around the center. Everything's turning around the center. It takes about 225 million years to orbit around the center. So it's going to be a
Long
while.
time.
So we are around again.
Yeah.
Now we have a irregular, really small galaxy about 80,000 light years away, which is
That's like
actually
next door.
it's very
It's right
close.
next door, yeah.
In case of distance and space, that's pretty close. It's
That
called
is.
the Sagittarius Dwarf Elliptical Galaxy, probably because you can see it in the sky close to the constellation
Sagittarius,
yeah.
Sagittarius, yeah.
Makes sense.
Anyway,
Cool.
now the closest,
Magma.
yeah. And here's some pictures to show you how big, like,
To give you
our,
an idea.
yeah, of how our galaxy looks, and also compared to some other galaxies the size. You will notice there's a giant galaxy called Virgo A that's
Huge.
much bigger. But anyway, now we're really close to another galaxy called the Andromeda Galaxy.
Yeah.
It's 2.5 million light years away, which, as I said, that's our closest major galaxy. So that seems really far away, but that's pretty close compared to
Right.
everything else in space.
Yeah.
And we predict that in about 5 billion years, we're going to actually collide with
Oh my God.
the Andromeda Galaxy,
That's
which is
gonna
going to
be
be the
fun.
end of the galaxies.
I am going to get bungee cords and strap everything down.
Yeah.
I'm
So,
not going to have it get knocked off.
but I think we're going to be dead because it's
I'm gonna dig a
55
big
billion
hole.
years.
That'll work, right?
No, I do. I exercise and moisturize. I'll be fine.
Yeah.
It's
So,
only 5 billion years.
kind of a fun fact that we wanted to throw in there at the end is that our wonderful Milky Way galaxy is going to reach its horrible end because the Andromeda is actually bigger too. So.
Well, I bet what all is going to happen is we're just going to mush into it.
Yeah,
So
you're
it's
going
not
to
like
have a
it's gonna
combination
blow
of
up.
matter,
We'll
a
just
lot
end
of
up with-
explosions, probably some more fusion.
A lot of planets colliding and suns colliding.
Ooh.
Yeah. Anyway, so that is actually it. Oh, there's the Andromeda Galaxy, though, if you want to see a picture of it.
Curse you, Andromeda!
But that is it. So do your checkpoint.
Do your checkpoint.
Checkpoint.
Although, what's the use? We're going to die in 5 billion years.